Right guys, so bearings part 2. These questions are going to start to get a little bit trickier, the next couple in particular, okay, and then we'll probably miss one out and then jump to the last one, which is probably the trickiest one you would ever get, okay. Let's have a look at this first one. So, in a race, boats sail round 3 buoys represented by A, B and C in the diagram below. That looks straightforward enough. B is 8 kilometres from A on a bearing of 60 degrees. That is marked on my diagram. C is 11 kilometres from B, also marked on my diagram. And A is 13 kilometres from C, also marked on my diagram. And I'm being asked to calculate the size of angle ABC, which is this angle in here. Now, straight away, I notice that I have a triangle where I have all 3 sides. When I have a triangle with all 3 sides, I can get an angle using cosine rule. And question A is asking me to get an angle, so I'm going to be able to use cosine rule. Now, to be in keeping with what we've done for most of this block, I'm going to change that to an A and that to a B, because we're trying to work out that angle there, so I'm going to call that cos A, which means my 13's little a, my 11's little b, and my 8 is little c. So cos A is b squared plus c squared minus a squared over 2bc, as I'm sure we are very used to doing now. Okay, so b squared 11 squared plus 8 squared minus 13 squared over 2 times 11 times 8. Making sure you've got all your numbers in the right place. Always worth double checking that at this stage, guys. Okay, you don't want to be getting this wrong just because you've typed your numbers in the wrong place or you've typed the wrong thing in. Always worth doing this on the calculator twice. Remember, I'm pretty confident you'll have plenty of time in any of these situations to double check these things. And we get 0.909090 and so on. Okay. Now, remember, that's not the angle. To get the angle, we need to inverse cosine that, because that's what cos of A is. Okay. And I've got that number still on my calculator screen, so I'm just pressing Shift cos to bring up inverse cosine, and I get 84.78. Now, bear in mind that when we're doing this work, guys, you really are thinking about angles and bearings where we would normally be working to the nearest whole number. So I'm going to turn that into 85 degrees because the question doesn't tell me how to round it. So the size of angle ABC is 85 degrees. Okay, hopefully relatively straightforward. Yes, it's kind of dressed up a little bit in a different question. But let's look at part B. This is where the bearing stuff's going to come in. Hence, find the size of the shaded angle. Now, let's just take out a little bit of some of my annotations here on the diagram. This is where I might be encouraging you guys in an assessment to draw a new triangle, just to give yourself some stuff and some space to think about. We're being asked to find the size of this shaded angle here. Okay, so this bit in here, the angle of the bearing from B to C effectively. Okay. Now, what you're really going to have to think about is a few different things here. And if you had never seen this before, you probably wouldn't think to do this. So this is where my teaching is really going to help you with these questions, guys. Because one of the things that it's really helpful to do when you're trying to find a missing angle in a situation like this is extend your north line. So this north line here actually keeps going. Okay, so you can have it all the way down like that, because a north line's just an imaginary line that gives you a direction. Okay, and so I have put it there. Okay, I've extended it so it goes through B and keeps going. I've drawn it as a dash line just because I find it a little bit easier. Okay, why is that going to help me? Well, watch this. Think back to first year probably, when you learnt about Z-shaped angles. Why is that a Z-shaped angle? Because it's involving 2 north lines, and the north lines have got to be parallel. Okay, it's kind of the whole point in this bit. The north lines are parallel, so from there we can identify this Z shape, the alternate angle. Okay, now what that means is that if this angle here is 60, then that angle in there is 60. Okay, now you might say, Mrs. Knack, how on earth does that help us get this angle here? Okay, well, if we know, I'm going to rewrite it because that looks bad. We know that this angle in here is 60, and remember what we just worked out in A was that whole angle is 85, then that bit that's left there must be 25. Now we're still not there, we've still not got the size of the shaded angle, but we're oh so close now. Because what we also know, remember guys, is that this north line that I've extended is a straight line. And what do the angles on a straight line add up to? They add up to 180. So the shaded bit, the bit that's left that we're trying to get, is going to be 180. Sorry guys, my tablet's been weird tonight. Take away that 25 that we've just worked out, and that'll give us this shaded bit here that's left. So if we do 180, take away 25, we get 155 degrees, and so that's the size of the shaded angle. Okay, so extending north lines and looking for Z shapes is sometimes going to be really crucial here. Okay, let's have a look at another question. Question number 5. Okay, now, a yacht sails from a harbour to a point C, then a point D as shown below. C is 50 kilometres due east of H. Now that's important. Remember what that means is that means this angle in here is 90 degrees, or also it means that that angle that way is 90 degrees. Okay, so that might come in handy. It also then tells us that D is on a bearing of 40 degrees from C. Now this isn't marked on, okay, our picture, but what that means, remember, is that D from C, so we're standing at C and we're measuring to D, that bit in there that I've coloured in red is 40 degrees, okay? Which means if I was to redraw this triangle, what we now have is that this angle here at C in the actual triangle is going to have to be 130 degrees because we've got the 90 from the fact that from C back to H we're going west, which is kind of 90 in an anti-clockwise bearing, an anti-clockwise direction. Okay, and we've got the 40, so add that on gives us 130. We know that this is 79 kilometres, and we know that this is 50 kilometres. Now, this is looking like a possible sine rule question if we're being asked to work out an angle. I've not even got to the question yet, I'm just looking at the possibilities. So, what does the question actually ask us? Part A does indeed say, calculate the size of angle CDH, which is this angle up here. So that is the angle we are trying to work out. Now, have we got all the right information for this, guys? We're trying to work out that angle D, and we know the side little d, so that's a good sign. And also, we know little c, and we know the angle C, so we don't have to do anything else. We've got all the information we need. We're trying to get an angle this time, so sine on the top, sine D, over D, which is 50, equals sine C, so sine 130, over C, which is 79. So sine D is going to be 50 times sine 130 over 79, and we type that into our calculator, so 50 times sine 130, remember closing any brackets that you might need to close, okay, to make sure your calculator deals with it properly, and I should get 0.484838 and so on. Now, not the answer, remember, that is sine of the angle. To get what the actual angle is, we need to do inverse sine of that, and we get 29.00. Okay, so D, the angle is 29.00, so really just 29 degrees. Okay, now hence, remember that word hence, it always means using what we know. Hence calculate the bearing on which the yacht must sail to return directly to the harbour. So let's go back to our picture. I'm going to get rid of all that information at the moment. Okay. We are at point D. That's where the yacht is. We want to know what bearing it must sail on to get back to the harbour. To get back to the harbour, we've got to sail on that bearing there, all the way round. Okay, now, how are we going to get that angle? Let me draw on this a little thought. So, first things first, we've spoken about the idea that extending the north line might help. Okay. Also, we know that from here to here is 180 degrees. Okay, because it's a straight line. And we also know, we've just worked out, that this angle in here, okay, slightly inaccurate, let me try again. This angle in here is 29 degrees. Okay, so what we need still is this little bit in here. Because if we add all three of those together, the 180, the 29, and then whatever that wee blue bit is, we've got that bearing that it needs to return back on. How are we going to get that? Well, we spoke about looking for Z shapes before, guys. What was the other bit of information we were told in the question? We were told that this angle in here, now the north line's not very big here, so I am going to just make it a wee bit bigger. This line here, this north line here, gave us a bearing here of 40. Okay. There is a Z shape. So that 40 must be the same as that bit that I'd put the blue highlighting in. So that must be 40. So to get the bearing, we're doing 180 plus 40 plus the 29. Okay, so 180 plus 40 plus the 29, making sure that we get an answer 249 degrees, which is just three figures. You do not write 249 point something. That is not a three-figure bearing. You need to just have three numbers. So these Z shapes with extending the north lines, okay, is what we're really trying to work on now. We're going to do one more question, guys. Okay. And that's this last one, 7. So you can try 6 yourself. It's not quite as tricky. 7 is the last one that we're going to do together. And I appreciate there's been an awful lot of listening, but this is how we would have done it in class. We would have talked through an awful lot of examples before actually trying them yourselves. Okay, and we would have kind of done bits and pieces. Okay. So, the 3 mooring points on Lake Sorling. A, B and C. From A, the bearing of B is 74 degrees, so that's marked on. Okay. From C, the bearing of B is 310 degrees. Now that's not marked on. That, remember, is from here all the way around to here. That's going to be 310 degrees, and that may or may not need to get marked on at this point. We first of all to find the size of angle ABC. Now, at this stage, guys, we have no lengths whatsoever. Okay, I know they appear further down here in the question, but that's after A, so we can't use that information. Okay, now, that therefore means it can't be sine rule, it can't be cosine rule, it's got to just be using all the angly stuff that we've done, the extending the north lines, the looking for Z shapes, etc, etc. Okay. So, let's have a tackle of this. Now, the first thing I notice is that there isn't a north line on B, okay? So that's the first thing I'm going to do, is I am going to get a north line put onto B, okay? And you'll notice that just to help with this question, because this one is a wee bit trickier, you can see that they've actually extended the north lines. Okay, so they've given you that little clue, because this one is just that wee bit trickier. Okay, now, ABC means we're having to work out that whole angle here. Okay, so I'm going to just get rid of that line again, so we've got space to work. And there's one that's quite obvious. So this bit here is 74. Looking at that Z shape, it means that this bit in here is 74. So that's part of the angle ABC. We know that it's more than 74 degrees, but what we're needing is we're needing to try and get this side. So we need to find another Z shape. The other Z shape is there, because if we have that little bit in there, it's the same as that little bit in there. But how are we going to get that? Well, we've not used this fact yet, remember. There shouldn't be any extra information in the question particularly. And from here, all the way round to here is 310 degrees. What's a full turn? A full turn is 360. So what's left must be 50. So if that is 50, then that bit in there is also 50. So the size of angle ABC is the 74 plus the 50, which is going to be 124 degrees. Now, how many marks would that be worth? Probably 2. Okay, on a bad day, just 1. Okay, but it's not going to be worth any more than 2. And that again is another wee clue that it's not a sine rule or a cosine rule question. It's just a work it out. Now we can do part B, which is going to be so much easier. But what I am going to say to you is that to do part B, you need the answer to part A. Okay? If you cannot get an answer to part A, make something up and put it as your answer to part A. So that angle clearly looks like it's bigger than 90 degrees. Make up an answer, say 110 degrees, put it as your answer to A, because then you can use it in B and get full marks for B. Okay, so this question will be worth maybe 5 marks if you make up an answer for 7A and then use it in 7B. You could still get 3 out of 5, which is going to be brilliant. Okay, remember 3 out of 5 in every question is a B, and you'll have got full marks in so many more other questions. Okay, so part B, calculate the direct distance from A to C, give your answer to 3 significant figures. Now, we now know that this angle up here is 124 degrees. We're told in the question B is 230 metres from A and 110 metres from C. We have an angle and the 2 sides either side of it, so it's cosine rule. And we're trying to get this length here, so let's call that A. Let's make that big A then. B and C, B and C. Okay, so A squared equals B squared plus C squared minus 2BC cos A. So A squared is 110 squared plus 230 squared minus 2 times 110 times 230 cos 124. Or whatever you have made up for this angle if you have struggled to do part A. Okay, so there's no excuses for not getting part B here. You can all do cosine rule. Okay, or you will all be able to do cosine rule by the point of doing the next assessment. Okay, but I appreciate that we won't all get all this bearing stuff. Okay, but we can all make up an angle for part A. Okay, get 3 out of 5 here. Right, when we work that out, we get A squared is 93295.16 and so on. Remember, a big number's not unreasonable here. Square root it, and we get 305.442 and so on. We're asked to round it to 3 significant figures, so 305 kilometres. Not kilometres, it's in metres. Okay, and that's how we do that. Now, there are a lot of opportunities for you to practice this week, guys, and I am available anytime you get stuck, anytime you need me to go over a question, so please use that.